Cirrus aircraft, the electrical system has been paramount in the operation of the aircraft. And the electrical system, in my opinion, is a genius design that makes it redundant and safe, and also provides the easiest user experience for our pilots. So the objective today is to understand the operation, the components of the SR20, 22, and 22 turbo electrical system. And as you can see, Cirrus, through this schematic, provides really good and in-depth information on these systems. So something that I want to touch on before I get started is where you can find the more in-depth information from these systems. So if you go to your Cirrus Approach portal and go to the Learning Catalog, if you haven't done this already for our students and anyone who else is interested, Cirrus just released a couple videos in the specialty section, including the CAPS course and the SR20 system, or the 22 turbo systems course right here. So you click on the course enrolled. As you can see, I'm enrolled. You go to the workbook, and there's a video for every system on this airplane. So where we got this information for our presentation was from this course right here. So you have the electrical system. You can see it takes about 30 minutes to complete, and it goes through the components and limitations, controls and operation, the distribution, and other important features of the electrical system. And you can see throughout the presentation, our slides are going to mirror this, because this is where you should be going for the information specific to the Cirrus aircraft. So we'll go back to our presentation. So we have the electrical system, and we're going to cover the components of the electrical system, the electrical distribution. We're going to talk about controls and operations, and then indications of abnormalities. So as you can see, the components of the electrical system is made up of 5 sources of power. You have the 2 batteries, the 2 alternators, and the external power. And you're going to understand how these systems work together in order to provide the electrical power generation for the Cirrus aircraft. And it also includes a 28-volt system with the, like I said, the batteries and the external power, along with the alternators. Alternator 1 is 100 amps, 28 volts, that is gear driven. And in the SR20, this is an important difference. It is belt driven on the Generation 6 SR20. So you want to make sure you keep note of that on your pre-flight when you're checking the electrical system. Alternator 2 is a 70 amp, 28.75 volt belt driven alternator. Make sure to take note of that, because that is important later on in this discussion. So what happens is the power rectifies in the, it goes from AC power to DC power in a converter. And then it goes into MCU, which is the brains of the electrical system. And like I said, all of this can be found in the Cirrus Approach Portal systems course. So the 2 voltage regulators control the alternators with an overcharge protection in the MCU. If it goes 3 volts above, it trips the MCU. And the modular design of the system provides efficiency, redundancy, and increased safety for operation. The main buses and the essential buses make up the electrical system. Battery 2 controls our essential distribution buses, and the diodes block the lower amp Alt2 from powering the main bus Alt1. And you can see the isolation diodes right here are one way. So one alternator cannot power the other alternator. The switches on the bolster panel activate the relays for their respective equipment, and we test battery 2 to verify that the diodes are functional. So if you go on the checklist, you remember for our students, when we flip battery 1 or 2 on, we're looking for certain systems to turn on and certain systems not to turn on in order to test the diodes that are functioning. The diodes are the gatekeepers in the electrical system, but 1 volt is lost in translation. When the diode measures an absence of 28.75 volts, it opens and allows the backup system to power everything. I mean, this is important because of the redundancies in the system. The switches on the bolster panel activate the relays for the respective equipment, and we start testing battery 2 to verify that the diodes are functional, like I said before. So when we switch on battery 2, we shouldn't see the flaps light turn on until we switch on battery 1. We shouldn't hear the audible fan behind the PFD until battery 1 is on. And the alternators do need a battery to start up. They are self-exciting, but if power to the batteries is lost and for whatever reason the alternators lose power, they're not able to restart without help from the battery. So when we're checking our indications for our electrical system, we're always referencing the MFD in our engine indication system. We can do this by pressing the engine indication soft key, or we have the little strip on the left of the MFD under the engine indications. We want to see a battery 1 amp in the positive to verify charging, and indications will vary depending on the load. So if you have more systems on, you'll have more of an indication. If you turn such as the air conditioner off, you're not going to be pulling as much energy, so you won't be charging as much because there's not going to be much as load on the battery. Power will automatically redistribute in the event of a system failure. So if there is a problem with alternator 1 or alternator 2, the power will automatically redistribute, which is one of the great system features of redundancies on these airplanes. If alternator 2 fails, alternator 1 can take over and power the entire system. If alternator 1 failure occurs, it will result in only the essential bus and the main distribution bus being powered. So as you can see, if alternator 1 fails, you lose more systems than if alternator 2 fails. And that's because alternator 1 can take over the entire system, but alternator 2 can't go and power what was on alternator 1. So you only get your essential bus and your main distribution bus. But if both alternators fail, you'll receive the following CAS messages, which is very important. The main distribution bus 1, main distribution bus 2, alternator 1 and 2, and the essential bus, CAS messages will appear. This is important because this shows that you have a dual alternator failure. If you had varying CAS messages such as alternator 1 out, you would have to plan accordingly for different scenarios. In the videos, if you when you watch them, you're going to see if you have a dual alternator failure, you're going to declare an emergency immediately, get to VMC conditions, and then you're going to land as soon as possible. But if you have an alternator 2 failure, you might not take that as seriously in your VFR conditions because alternator 1 can power the entire system. So depending on what messages appear on a CAS system is dependent on how you're going to troubleshoot that situation. But like it says in the abnormal slide, you want to notify ATC as soon as practical with any electrical problems. If alternator 1 failure occurs, what systems would you lose and how would you load shed? And if alternator 2 failure occurs, what would you do and how would you plan accordingly? So Mike, Orlando, if you have an alternator 1 failure, what would be the first thing you do to troubleshoot the problem?
Sorry, I'm gonna bring my audio back there. I had you guys all hidden. Bring the audio back. So I'm sorry, Brian, if you had an alternator 1 failure?
Yeah, if you had an alternator 1 problem occur in the airplane, how would you troubleshoot that situation?
Yep. So you would try and verify what systems are operating on under that alternator. See if those are still still operating, and then see if you could switch over to get alternator 2 to function.
Right. So if you go and when you watch the systems video, you're going to see that there is a checklist for everything on our MFD. So you can go over to the abnormals part of the checklist and check alternator 1 failure, alternator 2 failure, and what you can do and it gives you a step-by-step guide on how to load shed so you can make sure that you preserve as much power as possible. So the first thing you want to do is make sure you go through the checklist, which you would find on the MFD. And then depending if it's an alt 1 failure or alt 2 failure, you want to turn the appropriate systems off. And then if you need to make the decision whether you need to divert immediately or if you can make it to destination. So that's an important thing to remember is that there is a checklist for everything related to the CAS messages. So does anyone have any questions so far? I want to open up the last few minutes for a discussion on different scenarios we could have. So most of our students at Palomar Aviation are doing the private pilot course, so we shouldn't be flying in the IMC. So this takes a, this poses a good question on what type of operation we need for each alternator. So if you go to the POH in our airplane, and let me pull POH up for us quickly. Sorry, I should have had this pulled up earlier. So we have our POH pulled up, and we can go in the kind of operation equipment list. And of course, you should never take off if you have any pieces of equipment that are inoperative. But if you're in mid-flight and we have problems, the first thing you should reference are the CAS messages checklist. And then also, by determining whether you should continue or not, you should refer to the POH and all the checklists. So if you have an alternator 2 failure in VFR, you'll see in the kind of operation equipment list that VFR alternator 2 is not required. So you can continue to destination to replace that you have a Cirrus service center, so you can get that fixed. And you go right here, and this is a great resource for our students, the kind of operation equipment list right here. And you can see for electrical power, you have battery 1's required for everything, both type of operations. Battery 2 is not required, and neither is alternator 2 for day VFR and night VFR. So if you're having this situation in a VFR condition, you don't need to divert as soon as possible unless you have an alternator 1.
Can you hear me?
This is important. Yep.
Brian, are you sharing something on your screen? What we see up on ours says questions. Were you pointing to something by chance?
Thank you. I thought it reshared it. This is what I was trying to reference.
There you go.
Sorry
We
about
see
that.
it now. Thank you, Brian.
Very sorry about that. So if you're having issues in the air and you're unsure with what you're seeing on your checklist, obviously the smart thing to do is to land as soon as possible. But if you've read this equipment list right here, you can see that an alternator 2 failure in flight in VFR, you can still make it to destination or to a place where you can get fixed at a Cirrus service center and compared to an alternator 1 failure. And that's because of how the system's set up. So I just wanted to touch on that. Does anyone have any questions so far, or Aiden or Nick want to add anything in?
I think that was pretty well explained, Brian.
I think Steve was trying to say something, but he has his microphone muted.
I see you're using the SR20 POH, so that's why I couldn't find it in mine here. Okay.
Yeah, the 22 and 22 turbo POHs also lay out everything that you're looking for. Our students at Palomar Aviation fly SR20 right now, but we can go to the 22 POH.
Perspective Plus.
Yeah, right here.
One of the main things with the alternators that something Chuck and I talked about a few weeks ago is overall, to simplify things, you can think about alternator 2 as your main alternator, and alternator 1 is the backup alternator. If you can wrap your head around that, you pretty much can understand how that alternator 1 will actually power everything else in the event of an alternator 2 failure.
Yeah, and then here's in the 22 POH right here, the same deal. And Nick's right, how he just, the simple way to think about it is like that. It's when you're doing all your ground checks on the run up, it's a good feeling to know that you know what systems go off what alternator. When you want to check the air conditioning, you know it's going to come off alternator 1. The lane lights the same way. The nav lights and the pitot heat come off of alternator 2. So when you're doing your run up and you see those rises and drops on your EIS system, knowing what goes to what makes that decision making process in the air a lot easier. And you get that by studying the POH.
So Brian,
also,
Brian, this is Chuck. This is always a conversation that comes up, and I don't think there's a one straight answer, but I think the general wisdom, well, the checklists never tell you to turn off battery 1, say, in the presence of an alternator 1 failure, right? So
Correct.
the question comes up: isn't it better to turn off battery 1 and save it for when you need it? How do you reply to that question?
No, because you want the battery on at all time to power your systems. If you're getting to a point where you're saving it till you need it, you shouldn't be flying that long if you're having an electrical problem. You use what you need to use to make the right aeronautical decision to get yourself on the ground quickly, or just a place where you can get it fixed without, it's like fuel. You never want to be running on fumes. So you should never run your battery that long. If you know your system and you know that, and you've watched the videos, it says in the videos that the batteries last a certain amount of time. It's 45 minutes to an hour, 15 to 20 minutes. And so if you plan accordingly, load shed, you know what goes off of what, you make sure everything is turned off. You shouldn't need to turn the battery off and then turn it back on to when you need it. Just plan accordingly by knowing your airplane in the air. The knowledge is the power, really. The battery is great, but if you turn the AC off, you pull the camera circuit breaker on the bottom, the synthetic vision, stuff like that, you can save your battery and get yourself further on a lighter load. But you need to know where to look, which is in the portal, in the systems course, and then also the POH, and really understand what goes to what.
Very good. Thank you.
Yeah. And that's a good point. There's everyone comes up with some sort of trick, or this is how I do it, or this is the way that works the best from my experience. But Cirrus gives you such a standardized product with the IFOM and the Approach Learning Portal, and especially with all the videos that they've been coming out with. And there was an email that came out within the last couple of days saying that they were going to be putting out more content during this time to keep everyone engaged. So there's always a good way to stay on top of the airplane, keep learn the airplane better now while we're all on the ground. And then it'll make you a better pilot once everyone can get back to flying how it used to be. But I think that these Zoom calls are, once I learn how to share my screen better, will be will be really beneficial for everyone involved, because it can give us a forum to start that discussion that you can take back to your CSIP or TCI and really have a good conversation in depth about the systems course. Because if you're doing a transition, the first lesson is pretty in-depth ground on all the systems of the airplane, which we covered the CAPS last week, and then this week was electrical, and next week will be the fuel system with ADEM. Anyone else have any questions or point or comments?
Actually, not next week, Brian. I think that's on Thursday.
Thursday. Sorry about that. Every day is a week right now. That's the problem. There we go. I am still learning Zoom. This is my 3rd time ever using it. So I apologize for the snafu with the POH. Anyone else have anything, or should we want to wrap this up? Nick, do you want to add anything, or Aiden?
I don't have anything specifically to add. I think that sums it up pretty well.
Cool. Yeah. The last thing is, for all of those of us who have access to the airplane or are kind of grounded right now, you can go and learn a lot about the airplane through the external power if you don't want to actually run the airplane. There's a good talk in the portal about how to appropriately start the power unit and how to set the airplane up so you can use an auxiliary power while you're on the ground if you're not flying during this time. And I think that was actually a really good part was something that I watched the other day while I was getting ready for this presentation. But I appreciate everyone joining us. I hope that this was valuable and you learned something from it, and that you'll join us on our next presentation Thursday for Aiden's presentation on the fuel system. We are going to be doing these until we get back to normal flying at Palomar Aviation. But if you want to have an in-depth conversation with one of our CSIPs or TCIs, we do instruction through Zoom. I'm doing it with a gentleman in Hong Kong right now, and I think he's learning a lot about the airplane and the systems. But look forward to our next Zoom session with you guys on Thursday. Rick will be sending out that email, and I appreciate everyone's time.
Great.
Good job, Brian.
Thank you,
Thanks.
Brian.
Yeah.
Appreciate it.
Very good, Brian. Good job.
Thank you.